I'm Larry Davis. I'm one of the TSAs with Cook Air. I'm based out of Western Kentucky. Work out of the smallest Cook Air branch in Paducah. We have 8 TSAs total in our support group. When you need some help, you're out in the field, you're on a call, you need some technical assistance. If you call one of the branches, one of the Cook Air branches, and select option 4 for technical support, and if you'll wait on the line through all of the prompts, you'll be prompted to, or through all the options rather, you'll be prompted to leave a message for the technical support group. If you leave a message and you leave us your information, your name, your number, what you're working on, including model and serial number, then that message goes to all 8 of us at the same time. You have a much better chance of getting a quicker response than just trying to call each of us one at a time. So I encourage you, if you're out in the field, need some help, unless it's something you've been working with one of us specifically on already, use that general number and leave that group voicemail, and one of us will get back with you as soon as we can. So you got a question here for us here in training? Yeah, Rob, that should be okay. Yeah, as long as they're all plugged in individually, we should have that. All right. Yeah, again, any questions, throw them in that Q&A box, and it prompts me, and we'll try to answer that as we go. What we're going to talk about today is 2 different categories, but we're going to combine them together. We're going to talk about the new products that have the Puron Advance, which is Carrier's brand for the R454B refrigerant. We'll talk about what some of the similarities and differences are for that refrigerant compared to the 410A. We'll talk about, because of that refrigerant and its flammability classification, we have to have a means to monitor for leaks, and we have to have a process to mitigate an issue if there is a leak. That's our dissipation control. You'll see that information a lot through both presentations. We'll go over some of the installation similarities and differences. Some of the things, really, there's not a lot of difference. It's other than we have a few more controls, the dissipation control that's in there. And some of the things that were a best practice on the 410, you don't have a choice on the 454B. You have to do some of those practices, and we'll go through that. We'll talk about service practices. That's really where there's a difference in what you do every day with this equipment. We'll take a little break, then we'll switch over to the new furnace controls, which is what I have here beside me with the near field communication. Those have been out for quite a while now, not quite a year. So many of y'all have probably already installed these. Maybe there's some questions that's come up since you've installed those on how to set them up. We'll go through that and answer some of those questions. Maybe we'll talk a little bit about some fault codes you may have seen that didn't exist before. So we'll cover that. We'll talk a little bit about the IntelliSense product that's in the new mid-tier furnace and air handlers, or mid-tier units, and how that works. We'll touch on a little bit of the new products that's coming out now, and then we'll wrap it back up again with just an overview of the 454B systems, just to make sure that we cover everything we can on that and answer any questions you might have. So with that, let's go into the 454B and look at how it's going to impact what we do every day out in the field. Most of our slides right now focus on the residential ducted systems and the mini splits. The large mid-size and large commercial, is similar as far as changes in the refrigerant, but we don't really have a lot of that information in the slides. So we're really going to just focus on, looking at the refrigerant system itself, not necessarily on the large commercial products. Back in December 2023, there was an EPA final ruling for their technology transition program, part of the AIM Act. That's what's driving lowering the global warming potential and moving us into this new refrigerant product. So as you can see, the new global warming potential threshold is at 700, meaning any refrigerant or any air conditioning products produced after or installed after January 1st have to be below that 700 GWP threshold. So you see some dates there. We see 4 different categories: package units, split systems, mini VRF or ductless products, and then the larger VRF products. And there's some different dates there. A couple of those I don't think this slide's quite correct on, but the bottom line here is starting the end of this year, January 1st, 2025, if it's a new system going in, that new system has to have the low GWP refrigerant in it. In other words, if you have a system that you're installing after January 1st, it cannot be a 410A system. It has to be the 454B. You can replace components in a 410A split system or parts in a 410A package system. But if you replace the whole system, that has to be of the new refrigerant. Okay. And again, any questions on this, go ahead and put them in the Q&A box and we'll answer them as we go. The ductless system, that follows the same schedule as the split systems do. So January 1st, they have to be the new 454B or the new refrigerant, low global warming potential. Here's some definitions on what's different between a HVAC system and an HVAC product. A system is assembled and charged in the field. So if it has an indoor unit, outdoor unit, and a line set between, that's a system. If everything's all the refrigerant circuits self-contained, that's a product. That's a package unit. Okay. On a split system, if you have a compressor failure next year and you want to change out the whole condensing unit, you can still do that. That condensing unit is considered a service product for that split system. So you can change the condensing unit out. If you have an evaporator leak, you can change the evaporator out and put back in a 410A evaporator. But you can't do both of them at the same time. If you do both of them at the same time, that's considered installing a new system, and you have to go with the new refrigerant. Okay. On the package units, you can replace any component inside that package unit and move right along. You don't have to, if you have a compressor failure in a package unit next year, you don't have to change the whole unit to a new 454B unit. You can replace that component. 410A refrigerant is still going to be manufactured. It isn't like when we transitioned from R22 to 410, where 22 had a phase out date. Currently, 410A is going to continue to be manufactured, so it should still be available. So let's look a little bit at the history of refrigerant. Beginning back in the 1950s, I was not in the business then, but that's kind of when we started going to the R22. And it was around for several years until late 80s, early 90s, when the Montreal Protocol said, hey, we're destroying the ozone, we have to change refrigerants. That's when we went to the no ozone depletion, but it still had a high global warming potential. That's when 410A came out. And now we're at the 2025, and we're saying, okay, well, great, we stopped the ozone depletion, but now these products are creating a global warming potential. So we have to address that. And that is what is driving this switch to the low global warming potential 454B refrigerant. So we talk about global warming potential. There's a 700 GWP threshold. You can see 410A is at 2088, well above that threshold. R32, which a lot of manufacturers are using, and in fact, carriers using that in some of our commercial products, it's at a 675, whereas the 454B is at 466. So a lot of competitors are using the R32. Why aren't we using the R32? The reason carriers not using the R32 is there's an anticipated drop in that threshold limit in a few years. So the trend is thinking that they're going to go down to like a 500 GWP threshold. Well, if you're using R32, you're above that threshold again. You got to make more changes. The 454B at 466 is well below that anticipated next threshold. Gives us more time with the same refrigerant. Okay, so that's what's going on there. So what is in 454B? There's been a lot of miscommunication, misunderstanding. In fact, I thought the wrong thing for a while. Hey, this is a flammable refrigerant. It has propane in it. That is not the case. 454B contains about 69% of R32, but it's blended with R1234YF at about 31%. And that creates the 454B. So it has a low flammability. It is just above that non-flammable threshold. That brings it into that A2 category, but it's so low that, can you all hear me, by the way? So I got a screen saying I am muted. Somebody type in the Q&A if you can hear me. Okay, cool. Thanks. I'll ignore that little prompter then. All right, got it. Thanks. All right, so the 454B, it is a low flammability, and we'll talk about what that means. But, well, now I gotta get my cursor working again. Sorry. But it has no propane in it. Propane, as you can see on this chart, is an A3, high flammability. All of us has been in this business for a while. We deal with propane on furnaces or our grills or whatever. It doesn't take a lot to get propane to ignite. So R454B falls in this A2L category. In fact, the A2L, they had to create that, they had to split that A2 category because it was so low in the flammability that they kind of had to make a little different category for it. So one way it's been described, and y'all may have heard it if you've gone to any of the dealer meetings, is if you had a piece of charcoal with no fluid and you had a match and you're trying to light that piece of charcoal, that's about the flammability level of the 454B refrigerant. All right. It's very low, but it is above the A1 no flame propagation line. So because of that, we have some of these things that we have to do to deal with leaks and so forth. Okay. In my opinion, there's more concern about the oil that's in the system igniting than the refrigerant itself. But that's kind of my theories on it as of now. Flammability, the flame spread, it's less than half a mile an hour. So most of us can outwalk that. I was going to try to have a treadmill at home. I was going to try to take a video of my daughter, she's 7, and walking on that treadmill at a half a mile an hour just to show you that speed. But my treadmill wouldn't go down that slow, so I couldn't do that. The average person walks around 2.5 to 4 miles an hour. So if you were able to get this to sustain a flame, you can outwalk it. So no real danger there. But because it does fall within that A2L category, we have to, it has a lower flammability limit that we have to deal with. So what that means is that is the bottom of, if there's a certain concentration of refrigerant in the air, then it can ignite. So we have to make sure that we deal with that if we measure a level of refrigerant at that low LFL rather. So I think the ASHRAE standard is 50%. Our system measures it at 20. We instigate our dissipation system at 20%. You'll see that in coming slides. Now, what does that mean? So because of that, we have how much refrigerant per square foot is kind of how it's being calculated. You're going to see this chart in the outdoor units that have the new 454B refrigerant. What the chart says or is telling you is if you have so much refrigerant in your system, you need so many square feet of minimum floor area to be able to dissipate that refrigerant to get it to a safe level. So let's look at an example. That's called the A minimum check. So let's look at an example. You have a 3,500 square foot house. You put a 5-ton system in it. Let's say that 5-ton system has 11 pounds of refrigerant, just for example, okay? At 11 pounds of refrigerant, if you can look at the chart, you would need 167 square feet of space to dissipate that refrigerant safely, to get that percentage of refrigerant to air ratio down below the lower flammability limit. So 167 square feet, that's about the size of a garden shed, is what the example is telling us here. So if you're in a 3,500 square foot house, you have more than enough space to dissipate that refrigerant in the space so that we eliminate or mitigate the flammability concern. Okay. So as these products are coming out, people are going to hear stuff. Homeowners are going to hear things on the internet, how dangerous it is. This is information you can share with them to give them a level of comfort about it. So that brings us to our first poll question. Let me see if I can make this work. I'm going to kill the camera here for a minute. Polls. All right, so hopefully you see a poll question on your screen rather. Question is, a system with 15 pounds of charge, what is the A minimum of 454B? Is it 228 square feet, 1,000, 2,500, or 3,500? So based on the quick look we had at the chart, what do you think that answer is? All right, need to try to get everybody to answer this if we can. Give another second here. We'll go ahead and end the poll. All right. So let's look at the results here. About 75% of you said 228 square feet. And a few of you said 1,000, 2,500, 3,500. So what we were looking for here, the correct answer was 228. And I probably should have worded the question a little different where it said well, that is the A minimum. So what is the minimum square feet that we need to dissipate 15 pounds of refrigerant? So let me stop sharing that. Close the window out, go back to my presentation. So if I go back I'll go back and we look at our chart. I don't know if you can see my cursor here, but 15 pounds of refrigerant, we can dissipate that safely in 228 square feet. So, you know, even a large system or multiple systems in a home, your home square footage is going to be more than enough to safely dissipate that refrigerant in the air where we're below our flammability threshold. Okay. So let's look at some of the installation processes for this new refrigerant and see how that differs or it compares to the 410A system. Again, I mentioned this before, you're going to be seeing these charts in all the outdoor units on the charging chart. There's a section down below the min chart that tells you, that's where you'll write in the total system charge. So we'll talk about that here in another slide, but you're still going to have your charging chart, your subcooling scale, things like that. That's all still going to be in the unit. Those practices haven't changed. You're going to still use that same process to check the charge of the system. That label, to make sure we get the right information on there, that for areas where you have home inspections, then that lets that home inspector know that you have or how much refrigerant's in that system, so they can verify there's enough dissipation area for the total system charge. Okay, so that's what we're talking about here. You'll write that in a permanent marker, non-smearing, where it can actually be read. For me, if you ask my kids, they'll say they'll have to have somebody else write it for me. Just write it as legibly as possible inside that label. That's on the inside of the cover, so that you put that cover back on, it's protected from the weather, and should stay legible. If you're out servicing that unit and you see that it's wearing or fading, rewrite it and darken it in there. All right. We can't swap 410A and 454B components. Everything in that refrigerant system must be 454B compatible. So let's talk about what's in the refrigerant system. That's anything that contains a refrigerant. So if you have a gas furnace doesn't contain any refrigerant. So it is not part of the refrigeration system. So we'll see this a few times. You can put, if you have a system where you just changed the furnace out maybe this year or year before, and you get into next year and the AC system conks out, and you have to put in a new 454B system, you don't have to change the furnace. You can, this furnace can be wired in with the dissipation system and it'll work just fine. If you have an HVAC Partners account, log into that, go to the Learning Center. There's a couple of videos, actually 3 videos on there in relation to the 454B system. There's an industry safe application, the safety, storage, and transportation, and then there's the installation, which a lot of these slides are taken from. I'd encourage you, if you haven't already, go watch those videos. They give you a lot more information on handling and storing the 454B refrigerant. Just a key thing on that to note, majority of the time in our service trucks and our install trucks, we're not going to be carrying a large enough volume of refrigerant to require the placards that they talk about. And in your shops, you're likely not going to be storing the quantity of refrigerant that requires all of the safeguards and so forth. So for that reason, we didn't include a lot of those slides in this presentation, but I'd encourage you to go back and watch the videos just to get a good understanding of what we're dealing with here on that 454B refrigerant. What's different about some of the components? You'll see some of this repeated as well. Big difference on the refrigerant cylinders. The 454B refrigerant cylinders is going to be the left-hand thread on that fitting. So you will need to get that adapter that you see to adapt your hoses, your standard hoses and gauges. If they're mechanical gauges, they're suitable for use with the 454B. I'd encourage you to have a separate set of gauges just for 454B refrigerant, so you're not cross-contaminating systems. Your digital gauges, if they can be programmed or if they have the 454B scale programmed in them, then they should be suitable for use with the 454B refrigerant. If they don't, or they cannot have that, there's not a way that they can upload that, then they're not suitable, and you'll need to get a second set of gauges for the new refrigerant. Filter dryers, they'll be approved, or they'll say 410A approved or HFO approved. And the TXVs, just like any other system, the TXV has to match the refrigerant that's in the system. That's the way the power head is charged. So the new TXVs for the 454B, they have to be 454B expansion valves. They'll have mechanical fittings on them. The contactors in the outdoor unit, they're not a totally sealed contactor, but where before the top of the the plunger for the contacts went through the cap of the capacitor, or the contactor rather, that's going to be covered. And there'll be a little pinhole that you'll be able to use something small like an ink pen or something if you want to manually press a contactor. But they're more enclosing the set of contacts where that arc takes place to reduce the risk of an arc flash. Okay. And we'll see some more on that when we talk about servicing these things here a little later. All of our coils and units on the service valves are going to start coming with a straight stub out versus the swedged stub out. That allows for push fit or press fit fittings. If you want to braze that, you can still braze it, but it'll have to be swedged to make a braze connection there. If you're going to swedge it, don't use the hammer and swedge tool. If you're going to swedge it, use the clamp and the crank swedge tool, so you're not beating the daylights out of your tubing or the fitting if you're trying to swedge the fitting. I don't know, but I'd recommend swedging the fitting if it's me. Indoor units, this is kind of a standard practice. Just make sure it's installed securely, and we want to reduce the risk of that thing moving around and rupturing any of our refrigerant lines. Can't use these on airplanes. Not an issue in our area, but the maximum allowed elevation is 10,000 feet above sea level. Nowhere in our market is above that, so I didn't bother to find out what the reason was. Labeling, you're going to see a lot of difference in the labeling where it's going to say, hey, there's a refrigerant that falls into the A2L group. It's going to have a little flammability symbol on there. That's just a reminder on all the equipment. Again, indoor unit and outdoor unit both have to be 454B rated. Okay. Here we see again just some different hang tags and the different labels that are going to be on the system. You see the QR codes. If you haven't used those on our products, if you're out working on a system, you can scan that QR code and it'll pull up the installation information for that unit. Fan coils, the dissipation control that we've talked a little bit about already, it's going to come built in the fan coil already. Since the fan coil has the refrigerant coil already in it, that control is going to come in the coil pre-wired. The sensor that's there, we'll talk about it more as well. You may have to relocate that if you are putting that fan coil in a horizontal position. You will have to relocate it. There'll be instructions, and it'll show you exactly where to put that sensor. All right, ductwork. A lot of questions on this slide, and I don't have a lot of answers. We're going to talk a little bit about accessories like air cleaners, air purifiers, humidifiers, things like that. We have to verify that there is not a potential ignition source there. We're using our ductwork to dissipate our refrigerant if we have a leak. And you'll see how that, we turn the fan on and circulate the air because our coil sits inside the airstream. So we're going to use that movement of air to get rid of the refrigerant and to mitigate that. So for that reason, we can't have anything in the duct system that can be a potential ignition source. So we'll see how that works here in a little bit. Supply and return duct must be directly ducted to connected rooms. Okay. So what they're saying here, and you see at the bottom bullet, using a false plenum or an open return above a lay-in ceiling, this is saying that that's no longer going to be acceptable. We've asked for some clarification on that, haven't really gotten a response or, why that is. My guess is the reason for that is majority of the time, and it's a light commercial application, you have an open plenum above a ceiling and you have the supply duct running through that plenum. I think maybe the concern there is if there is a leak in the supply duct, then we're just recirculating air and we're not getting the full dissipation. We're not being able to use the full square foot of the building to dissipate that refrigerant. Questions come up. They consider the I wave as a potential ignition source. Anything that has power running to it is considered an ignition source. So we'll see here in a few slides how to deal with that. Good question. So on those accessories, review that and compare that manual to see if it's suitable for use or if there's any changes that need to take place for 454B installations. One of the big changes on electronic air cleaners. There is a chart, it's way at the end of the last presentation, I think, that says for certain voltage, if it has a certain amp rating, if it's above that, then it's a potential ignition source. None of our accessories meet that threshold. However, there is a requirement that there has to be airflow proven before you turn on an electronic air cleaner. So that's what you're seeing here, and you'll see it again. If you're putting in an electronic air cleaner, an air purifier, it has to have the airflow proving sensor in it. If you're putting in a fresh air ventilator, we just have to make sure that we are not recirculating air. So typically, if you install that according to its installation manual and guidelines, where you're not recirculating that air, then you should be fine. Okay. Oh, here's the chart. It's well ahead of where I thought it was. So there is this chart exists if for any particular refrigerant, this is what the single phase amp rating or amp draw would be at any given voltage. Anything above that is considered an ignition source. As you can see, we're nowhere near that on any of our products. However, it is required because it can produce a spark in an air purifier. It's required that you have that airflow sensor in it. A lot of the new ones will come with it. If it does not, then there's a kit number that you'll have to add. Excuse me. And this is what I just mentioned on an air purifier. Just follow the instructions and you should be fine on that. Poll question 2. We are moving right along. Poll question 2. So we just looked at that chart at 110 volts. What amperage is considered an ignition source? It's much higher than anything we would ever have. So keep that in mind as you're answering. I'm going to try to get everybody to answer this. We'll leave it open here for about a minute. Let's see, questions come up. Will the air sensor be required on a polarized EAC that is powered by 24 volt? I am going to say yes. I think I haven't seen anything specific, but if there, it's an electrical device in the airstream, so I'm going to suspect most likely, yeah, it's going to be required. I'd probably, if it was me, I'd probably go ahead and put it in anyway, just to cover my bases. Good question. All right. Well, we got almost our 94% of our group answered the question. So let's go ahead and in the poll here, and let's share the results. So at 110 volts, what amperage is considered an ignition source? If we remember from our chart, it was that highest number, 57 amps, well above any ancillary device or auxiliary device or accessory that we'll have in our system. So most everybody got that answer. So we'll stop sharing. Another question has come up here. Will the ports on the unit be left-hand thread? No, the ports on the unit are standard. So you can hook your gauges up, your standard hoses will work on the unit. It's just like a LP tank on your grill. We just want to make sure you're not hooking that tank up to something else. So that's to help prevent accidentally charging 454B into a 410 or another system. But your unit connections are going to be the same. You can accidentally charge 410A into 454B system all you want. It just won't work worth a hoot. All right, let's look some more at our dissipation system. So the way it works, we have a leak sensor. We have a sensor in there, and it's tied to a mitigation board, or a dissipation board. Okay. When it senses a refrigerant level above the 20%, it's going to go into a dissipation mode. It's going to stay on for at least 5 minutes. When it's in dissipation, there's a little light on there that'll tell you that. It shuts off our heating and cooling system and energizes our indoor blower. It's going to run that blower for a minimum of 5 minutes. Okay. Once that sensor has cleared, then you will it goes for a 15-minute total dissipation. It's going to be in dissipation for at least 15 minutes. Okay. And then once it sees that it's staying below that threshold, it will actually allow the system to go back to heating or cooling. Now, obviously, if we've had a refrigerant leak, our cooling's not going to work. So you're going to get called out on a no cooling call, but it does allow the furnace to kick on because we've mitigated the amount of refrigerant that's in the air. We're well below any concern for flammability there. Questions come up. Let's see, 80% furnace in a small closet. The refrigerant comes apart, blowing charge into the closet in a few seconds while the furnace is running. What happens? So we're looking at an 80%. You should have dilution and combustion air coming into that room. So if you're asking, is there a question that's going to ignite? Yeah, there's a possibility that will ignite, but where's it going to ignite? We're pulling air through the heat exchanger. It's going to ignite at the point of it, at the end of the burners. What's going to happen? Is it going to cause a big explosion? I doubt it. haven't seen it tested, but I take that back. I know they've tested at the lab this similar scenario. In fact, in some of the slides we'll see, they're hooked up to an 80% furnace. The key there is monitoring that. What I would suggest, if you wanted to be double safe about it, add a second dissipation system. You can see you'll see that as available here later on as a third-party product or an aftermarket product. Add another one for it and sense it out in the closet if that's a concern. That way, if a line leaks in the closet, then you'll sense it in the room, shut the furnace off, run the blower. You're really not going to dissipate much because you're leaking into your closet, but it'll at least shut the blower down until that sensor says it's a clear. But I really don't know how often something like that's going to happen. What's going to happen? How often do you have a line blow versus a coil leak? But it's a good question. Good question. Okay. So bottom line, once we go into dissipation, we're going to be in dissipation for 15 minutes. Okay. That's just kind of a minimum. As long as it's going to be at least 15 minutes till we get an all clear. Okay. So how does it work? The sensor is in the coil area, is installed at a specific point that the factory recommends. Once that sensor picks up a lower flammability limit of 20%, again, the ASHRAE standard is 50%. We're tripping at 20%. Once we get above 20%, our sensor sends the signal to the board. Board shuts the system off and runs the blower. Charging systems. We kind of bounce back to the install here a little bit. Charging systems, just like charging with 410, it is a blend, but it's your glide is very negligible. So you can charge it, it's recommended to charge it as a liquid, but you charge it just like you do with our 410 systems. You're going to do a thorough leak check, and we'll talk about those practices are a little bit more thorough than what was acceptable for a 410A system. I've said this before, 410A and 454B components, coils, they're not interchangeable. You can't use a 454B coil on a 410A system and vice versa. Can't use a 410A coil on a 454B system. If you're doing a change out on a split system, it's like I said, if you are just changing the outdoor unit, you can go back with a 410A outdoor unit. If you're just changing the indoor coil, you can go back with a 410A coil if it was originally 410A. But if you're going with a new 454B unit, you got to go indoor and outdoor. Line set's not going to change. Our line set sizes are going to be about the same as they are for 410. The oil, we're still using the POE oil, so we don't have to worry about a change, having the old mineral oil in there like you did on an R22 system. If you have R22 lines, I'd change them out. You're well past time to change those out. And you could have some oil compatibility issues. So if that's an old line set in there, that's R22, change it out, put a new line set in. So Puron Advanced coils only with the Puron Advanced 454B to 454B. Make sure you can get a ratings in the ratings database for that matchup that you're putting together. So again, on our evaporators or fan coils, we have the dissipation board, we have the straight stubs, we have the new TXVs with mechanical fittings, the sensor that's in there. On the outdoor unit, you're going to see red caps versus the old black. That's going to be an indication of, hey, this is a 454B. That along with the labeling on the unit. You will have the straight stub outs where you can use the press fit or the mechanical fittings versus brazing. If it's a heat pump, your outdoor expansion valve will be rated for the 454B. The wire going to the compressor is encapsulated versus what we see on the current units where it's just the 3 wires going down. Wires going down to the compressors encapsulated as part of the molded plug. Trying to think, you're going to see you'll see a major change in the model number nomenclature. For example, for Carrier, on a heat pump, or if it was a 25, it's going to 27. If it was a 24, it's going to go to 26. So you'll see a significant identification in the model number that says, hey, this is a 454B system. The filter dryers, again, they're going to be rated for the 454B and they'll have the straight stubs as well. So the question is, do we have to change R22 line sets no matter what? You don't necessarily have to. If the line size is correct, you should be fine reusing that line set, but you're going to have to really flush that system out before you put in the new product, because what we don't want is any mix of that old mineral oil or that old R22 refrigerant into this new 454B system. So yeah, if it's still a running R22 system and you're changing it out to the new 454B, you're just really got to make sure that line set's clean. You're gonna have to flush it. Let's see, grab these questions here. Yeah, line sets that are not accessible, as long as it's the right size. If it's the wrong size, we run into this a lot. The old R22 heat pumps, you were able to run a 5/16 liquid line on a lot of them. Heat pumps, even with the 410A, they have to be 3/8 liquid line. So, and there's some cases where you just don't have a choice. You got to change that line set out if it's the wrong size. If it's the right size, you just got to do a really good job of cleaning it out. Key for the caps on the service port. I haven't seen anything about the caps being locking. So to my knowledge, they're just a red cap versus a regular black plastic cap. So to my knowledge, there's no key on that. I look at the mitigation or the dissipation board. It's the same board regardless of what equipment you're using across the product line, whether it's the basic series or builder's models, the mid-tier, or the communicating system. Dissipation board's the same. You have a plug for the sensor. You have a plug for the wiring harness. You do have an alarm output. So if you wanted to hardwire an alarm to something, hardwire it to an alarm to say, have a light go off if there's a dissipation taking place, you can do that. And if you're on a communicating system, you still have that ABCD communication plug that you will use. On the communication system, and you'll see this a little bit later as well, if it's on a 454B system and you're using a communicating wall control, it's not going to run until it finds its dissipation board. So you have to wire it up for communication. It has an LED on it that'll give you the status. If there's a code, it'll flash. If everything's hunky-dory and it's powered up, the light will be on solid. But if there's a fault, any one of these faults, it's going to flash that code for you. Okay. Sensor testing. There's a question of, how do we check this, make sure the sensor is working properly? One quick test is to power it up, give it 10 seconds to warm up. When the light comes on and is steady, unplug the sensor. And you should get that fault code too. And it should go into the dissipation mode. And then we'll see here a little bit later, there's some ways of measuring voltage on the sensor itself. For the evaporator coils or the V coils or A coils, the sensor, that dissipation board is going to be externally mounted. The sensor runs through a cable through a grommet. You see the straight out stubs there again for the coils. Runs through a sealed grommet and the sensor is located. If the coil is a multi-poise and you're in horizontal, there'll be instructions on where to relocate that sensor. Here's the same thing for the A coil. You see that sensor, it's just mounted low. The refrigerant's going to want to accumulate low in the area, so that's where it's going to pick it up. Slab coil, don't know if anybody still uses those, but uses, yeah, there's there. Same thing for the location for the sensor. Question is, board in addition to the blower control board? Yeah, it's a totally separate board. If you're using it on a communicating system, and you'll see it in the wiring schematic, we don't use on our communicating systems, typically like when you're powering up your wall control, you're using C and D for your 24 volts for the wall control. We don't use that on the dissipation board, where you'll still wire R and C to the dissipation board. Now, the thing about that, and the reason for that is we're sending power to the dissipation board before it goes into the furnace control. If that fuse blows on the furnace control and it shuts power down to the furnace, our dissipation board's still going to be powered up. So it's just kind of gets to the priority level, if you will. But yeah, you'll still wire R and C to the dissipation board. So looking at a little bit of the wiring here, and you're going to see this a lot this morning. You have a wall control where you have the 4 communication wires running to it, and the ABCD or RC, DX minus, DX plus, depending on what you're dealing with. That goes from the furnace control, to the dissipation board where you're only wiring A, B, and C. And then you see it goes from there to the outdoor unit. Just a daisy chain or zone board, all that fits in the same daisy chain. And the C going outdoor, that depends on, again, on the unit you're using. There will be a dissipation terminal on the furnace board that you'll wire the G out from the dissipation board to that. And what that does is that provides that output to tell the blower to come on when you're in dissipation mode. And again, you'll see the secondary 1 and common, we're wiring straight from those taps to the dissipation board. If you're using, and we gotta have better slides of this going forward. Your Y call from your thermostat and your W call from your thermostat go through the dissipation board. It has second level priority before the system. And what I mean by that, if your thermostat gives a call for Y, the dissipation board has to say it's okay to run cooling before it'll bring the cooling on or heating. So the dissipation board shuts off your cooling and heating if it sees a leak and it's in the dissipation process. All right, we're going to take a little break here. I'm going to kill the camera. And this is a moment where you'll go ahead and let's take about 5 minutes and everyone put your information in the chat again. Again, this is required to say, hey, yep, you're still attending the class. You're still here. You haven't left. That's required for us to get these classes approved for credit hours. So let's take about 5 minutes or so and plug your information in there. If you have any questions, throw them in the Q&A box and we'll take a run at it. Hey, Adam, I think you put your information in the Q&A box. I need to have you put that in the chat box, please. All right, we'll give it another minute or two here to make sure you get that done. Again, we need that information for your credits. Questions come up. Will 410 products still be manufactured for the next 10 years? I don't know about the next 10 years. There is a manufacturing through range, but I don't know that it's 10 years. If you're asking in regard to the 10-year warranty on the high tier product, what I've seen is, especially with a ductless, where they've discontinued a product line and the new one's not compatible, then they will warranty both pieces of the equipment, the indoor and the outdoor. So if it gets to the point where they're not making a 410 product anymore, and you have one that's still within that 10-year replacement warranty, and it has to be replaced, then it'll just go with the new 454B, and you'll have to replace both components, and they'll cover that. They offer dry ship. No, the outdoor units are still going to come charged with 410A. Again, 410A refrigerant is going to be available for the foreseeable future. This is not like the R22 changeover that we did back in the early 90s. 410 is still going to be available. And again, the units are going to be produced for service, kind of like we were talking about earlier. But I don't know that I would stand here and tell you 10 years, yeah, you'll still have a unit. But you should still be able to get 410A refrigerant. And as long as the 410A outdoor units are going to be produced, they're going to be produced with refrigerant or shipped with refrigerant in them. All right, we're going to roll on. If you didn't, please make sure you go in and plug your information in here. We got a few more times we have to do this. Just make sure we have that information. Let's look at some wiring diagrams for these new systems with the dissipation control. So here you see, we've looked at this before. It's a standard fan coil with the a straight AC unit. Your commons all tied together. Your call for heat from the thermostat goes through the dissipation board. And then you have the heat call out that goes to your different stages of heat for the fan coil. Your R powers everything up. This drawing is a little bit wrong in that it's showing your dissipation board getting its R from the R terminal in the fan coil. That's not correct. It's going to come from the transformer taps, not the R terminal. Same, and that's going to be the same on all these drawings. That's incorrect. With two-stage heat. So the interesting thing here that I think the drawing is incorrect as well, on a heat pump, we have our W2 output from the heat pump to give us heat when we're in defrost mode. And they show that wiring in between the dissipation board and the fan coil. I don't think that's correct. I think that should wire in on the WN, the same as the call from the thermostat. So as these products start coming out, we'll get some clarification on that. But to me, I think that'd be the correct way. On all of them, you see the G out and the G in, everything goes through that dissipation board. It has some level of priority on, the thermostat can tell it to call, but that dissipation board is what allows things to run. And we also want that G output to the dissipation board to be able to energize that fan in the event of a dissipation. Okay. For manufactured housing, the difference there is the thermostat on your electric heat. And again, I question the W2 output from the heat pump as to whether that should be landed on the WN versus W out. Here we're just showing the green plug for the communication system, then the ABC wired to it. Shown you this before. This is where we gain time. Again, the key thing there is we still have to wire up your 24 volts from the secondary one on the furnace board. On your evaporator coils, once again, just reiterating that it's going to have the labeling on there. Now, you don't want to disrupt or tear up that label. Make sure it's still legible. Try not to smoke it with a torch if you're brazing. And make sure that sensor is in the correct location, especially if you're on a multi-poise coil and you flip it to horizontal. Dissipation board for a furnace fan coil, it comes with the furnace and evaporator coil. Dissipation board comes with the indoor coil, not the furnace. So you'll see it here. You can use this, a 454B system, on any furnace, as long as you wire that in to the control, as you'll see in the instructions. Does the dissipation board come with a wire harness? Wire harness is provided. Oops, I always forget to reset that. As of right now, our outdoor units are not rated with third-party evaporator coil. or our furnaces because we don't know how they're doing their dissipation control. So we can use our outdoor unit with our evaporator coil and a third-party furnace because we're using our dissipation system. So that's really what the difference there is who's who's running the show as far as dissipation goes and how's it done. That dissipation board on the evaporator coils, it comes in an enclosure with a wire harness that runs from the board to the sensor and a harness that runs from the board down to the furnace to wire it up. Make sure that enclosure is installed upright where the harness comes out the bottom. You just don't want moisture, things like that to get in there. So that's what we're talking about here. You want to mount it where it's visible. You don't mount it inside the coil box, the ductwork, or the furnace. And the wires go out the bottom. You want to be able to see that LED. You don't mount it outside where it get rained on or dripped on, things like that. So a question, can you bypass the dissipation board? Board sensor goes bad. That dissipation board is a safety device, just like a high pressure switch, low pressure switch, or high limit cutout on a furnace. No, it cannot be bypassed. Will these be included on new mobile home units? We don't produce mobile home units. We have certain, I don't even think our fan coils are rated for mobile home use now that I think about it. It's going to come with the evaporator coil and it's going to come built into the fan coil. So if it's a 454B unit and it has the coil, it'll come with a dissipation control. Good questions. And we're already up to poll question 3. So let me launch poll question 3. Poll question 3. I don't know why that's here. I got ahead of ourselves. When is a single evacuation during recovery process not sufficient? Go ahead and take a run at it. I don't know. This slide got out of place somehow. I don't know how. I may have done that. I won't hold this open very long. Give you a pass on this because the question's out of place. All right. I'm gonna go ahead. Well, there's a few more people answering, taking a shot at it, but it's not looking good. So I'm gonna go ahead and end this one and share the results. I apologize. This slide it's out of sequence. We haven't even talked about this yet. When is a single evacuation during the recovery process not sufficient? It is not sufficient when you're recovering 454B from an existing system. Any other time, if you're installing a new one that's never had refrigerant in it, you can do, you're fine for single evacuation. If you're recovering 410A and putting in a 454B, single evacuation's fine. And then the bottom one is not correct. So the correct answer was the top one. If you're pulling out 454B refrigerant, you're recovering that. You cannot do just a single recovery process. You have to do multiple recovery, and we'll talk about that. So my mistake on the presentation there. I got to fix that for next week. All right. So back to the question, back to our dissipation board. There's a wiring harness that runs from the sensor to the board. It's a plug on each end. And the wiring harness from the board has a Molex plug on the board, and then it has terminals on the other end. And those terminals will be labeled to exactly where they go. So let's look at some more wiring diagrams. Again, you've seen this one, single stage. Not sure why I show the R going to the outdoor unit, but if it has it, it'll go straight through. Okay, same thing here. Hang on a minute, I got a screen in the way, I can't see something. Yeah, so this one's a little better. Let me just get this down here out of my way. This one's a little better where it's not showing us wiring our R to the dissipation board. You're seeing it coming from the secondary one on the furnace. And same here. So this is more accurate than the previous wiring diagrams that we were looking at. Okay, and again for a two-stage, if you have any questions, we've looked at these. It's pretty straightforward. The outputs from the thermostat have to go through the dissipation board before they go to the furnace. Now, one thing that you'll notice on the Y2, on a two-stage outdoor unit, there's not a Y2 terminal on the dissipation board, okay? And the reason for that is our Y2, all we're doing with that is energizing a solenoid. So if we go into the dissipation mode, we're going to kill our Y1, our compressor is going to stop anyway. So there's no point in breaking that Y2 through the dissipation board. That'll just run straight through to the from the thermostat to the terminal on the furnace to bring our fan into high stage during Y2, and then right out to the outdoor unit. Same thing on the heat pump, the reversing valve. There's not a reversing valve terminal on the dissipation board. It goes straight through and wires up just like normal. This is a video that kind of walks through that. I think for the sake of time, and I don't know, yeah, we'll try it. Let me know, there's audio with this video. If you're not hearing the audio clearly, let me know and I'll stop the video. Are you guys getting the audio with that? No. All right. We'll go ahead and skip past that. All they were walking through is what we just talked about on wiring it up. So that harness will come down. You'll see the R has a piggyback on it. You pull your secondary one off and plug that on, plug your secondary one back on. You're out to the furnace and then on out to the outdoor unit. And you're in from your thermostat wire nuts to the wires in the harness. Okay, they'll all be clearly labeled. LED lights, there's a status light that'll tell you again the code that we were seeing. There's a comm light. That comm light's only going to be on if you're using the communication on the high tier products. Other than that, the comm light won't be on. And again, there's the chart that will be on the cover for the coil, that comes with the evaporator coil for the gas furnace application. The mounts in that external box will be on there, and the fan coil the label should be inside the fan coil. Okay, so there is a test button. All right, and there's several different, if you're out on just a routine maintenance on one of these systems, you can use that test button, and based on what call you're getting from the thermostat, what the recommendation here is, if you're not calling, give it a call for cooling, give it a call for heating, and then press the test button and make sure it goes into that dissipation. It'll go into it for 60 seconds, and then the LED will go back to solid, and it'll run. What do you want to make sure it does? It stop your call? Does it make sure the fan is on? And does it go back out after the dissipation? Okay. Let's talk a little bit more about testing the sensor when we're troubleshooting these things. The test button will allow you to check the board to make sure the board's doing its thing. Now we want to test the sensor. So the one way is to pull it like we talked about before. Power it up, make sure you have a solid LED on the status light. Pull the harness for the sensor. If it starts flashing the fault code 2, then that's the sensor no longer communicating. So that tells us that the sensor was communicating before. So this is another video that we'll skip past. So checking the voltage from your board. The outer 2, there's 4 pins going to that sensor. The outer 2 are a constant 5-volt DC power supply to the sensor, and the inner 2 terminals are the communication between the sensor and the board. So the board provides 5 volts DC to the sensor on the outer pins, and then the sensor communicates with the board on the 2 inner pins. So checking that, make sure you have power on your board. Do we have 24 volts on our board? Is our light on? Remove the sensor. Measure the DC volts on that harness between pins 1 and 4. Should be about 5 volts DC. If it's not present, check it back at the board. Do you have a broken wire in your harness, or is the board not producing the DC voltage? Measure on your inner pins. With the sensor disconnected, should be about 5 volts, very minimal fluctuation between those 2. So it's sending that out looking for a feedback signal. And if it's not there, then check again at the board. Make sure you don't have a break in the harness. If you're not seeing it there, then the board's bad. Reconnect the sensor. Our 5 volts on the outer pins should not go away. It should still stay there. If we lose our 5 volts DC, we have a shorted or a failed sensor. And then finally, measure with the sensor connected, measure the inner 2 pins, and you should be seeing about a 0.02 to 0.2 volts DC fluctuating. And if that's not changed from before, then you have a bad sensor. Okay. On the question was asked on the communicating system, will it show a fault on the thermostat on the wall control? Yes, it'll show a fault on the wall control. Okay, let's look a little bit more at installing. Your tools, all your recovery machines, vacuum pump, digital gauges, leak detectors, all of that, they have to be rated for the 454B refrigerant. Okay, so you need to verify that. If they're not, you'll need to replace that tool with one that is. Best practices when you're installing. If you're installing a new system, you want to make sure that wherever you're working, you have an adequate air. One of the things they're recommending is having a leak detector turned on and sitting next to you while you're working. And if that leak detector that is rated for use with 454B, if it goes off, that is your notification that there's a refrigerant present in the air, and you need to, you need to mitigate or dissipate that refrigerant as soon as you can. Your vacuum, you're going to get down to a 500 micron level vacuum. Make sure it holds for 10 minutes, and then you charge with the liquid. Okay, that's on a new installation. So comparing the two, on charging them, you can't vent either refrigerant. So that's been a standing rule that hasn't changed, even though, now we have a refrigerant that has a low global warming potential and no ozone depletion. We still can't vent it. We still have to recover it. Okay. You charge in the subcooling mode with the TXV, that hasn't changed. You want to look for the ideal temperature range, which means 70 to 100 degrees outside and 70 to 80 inside. If you're not within those ranges or can't get within those ranges, weigh the charge in. Always come back on a day that you can get within those temperature ranges and double check your subcooling. Okay. New or existing line set. You're recovering refrigerant. If it's a 410, you just go through your standard recovery process. And then when you change your units again, I just recommend flushing the line set. This is back to that poll question we had earlier. It was out of whack. I'm hoping Yeah, we'll see. All right. On a new 454B with new piping, you do a purge with nitrogen, you're doing your pressure test, and the single evacuation is fine. If it's a new 454B system that you took out an old 410A system, you've recovered that 410A refrigerant, you just do a single purge and a single leak test and then a single evacuation, and that should be fine. If you're changing out a 454B system or component with another 454B, in other words, if that system already had 454B refrigerant in it, you're doing a double evacuation. So what does that mean? That means that's not there yet. Well, it should be one of these slides coming up. You evacuate, you recover the refrigerant, you evacuate the system to, I think it's 1,000 or 1,500 microns. You break that vacuum with nitrogen, then you evacuate it again down to, I think, 500 microns, bring it up to 0 PSI with nitrogen, then you can open it up. So we'll talk about that process here pretty soon. If you're working on a system, you're servicing a 454B system, you have to fix something on the indoor coil or line set. If you don't have to access the condensing unit or anything in there, you can still pump it down and isolate it through the valves. Okay. All right, here's the process. Talking about the double evacuation. You recover the refrigerant, and this is required with the 454B systems. It's not a best practice. You have to do this. You double evacuate it. You purge it after recover it. You purge it with 2 to 3 pounds of nitrogen. Release that nitrogen. Evacuate to, just 500 microns. My mistake. Not to rise above 1,500. That was the number. And then you repeat the nitrogen purge. And after that double evacuation, so it's recover, purge, evacuate again, and then break it to 0 with nitrogen, and then you can open up the system. Okay. Let me grab some of these questions here. Let's see. For refrigerant checking, how does refrigerant react with using a charging jacket? I'm guessing that you're talking about covering up the condensing unit to get your pressures up. It's going to react the same as 410. So while that is, somewhat of an acceptable method of trying to get your head pressure up and check your charge, best practice is to return to the job when the temperatures are within the ranges that you were seeing earlier, where you're above 70 outside but below 100, and inside you can get that indoor temperature to 70 to 80 and get a little bit of load on that system. That's when you're going to want to check your subcooling. Okay. But as far as using the blanket on the outdoor unit, it'll do just the same as a 410A system. Okay. So again, when you're doing a repair, after you've done the double evacuation, you made your repair, you're going to do a leak test with nitrogen. You're going to evacuate it, and then you're going to charge it just like before. The big thing is when you're opening that system up, that double evacuation with the purges with nitrogen in between, to make sure you get any pockets of the residual refrigerant out of that system. I talked about this earlier. Aftermarket strategy. Use a dissipation board with a sensor and a control box enclosure with the labels. I mean, back to the question earlier about a 80% furnace in a tight closet. If you wanted to go through and put one of these in that closet to do the same process, maybe tie it to an exhaust fan or something. I mean, that's a possibility. Replacement components, again, make sure when you're replacing a dryer, expansion valve, especially the contactor, you don't just grab one of the old contactors off your truck and throw it on there. Make sure it is a contactor that is rated for use with 454B refrigerant, that it has those contact points sealed. Okay. So questions come up back on our double evacuation. So what happens if someone doesn't bring the second evacuation back to zero with nitrogen and just opens their gauges? You're sucking in air into that system and introducing non-condensables and moisture. So that's the reason. Anytime you break a vacuum, you have a system down to 500 microns. We've dried that system out. We've cleaned it out as best we can. We want to break that with clean nitrogen. We don't want to just allow air to come into that system, or more importantly, moisture. That gets back into the system, your next evacuation after the repair is going to take a lot longer. All right, good question. Tools, we talked about the tools. Make sure that your tool is rated for the 454B refrigerant. Again, you'll need that left-handed adapter for the tanks, but your gauge hoses should be the same. All right. Question 4. Let's see what happens here. I think I know what happened. Nope, it's right. All right. So question 4, what should be considered regarding A2L service items and tools? Make sure you have ventilation and leak detector is adequate and A2L compatible. Service equipment, vacuum pumps, so on are compatible. Gauge manifold charges dedicated for a 454B system, or all the above. What's the best answer there that you see? I'll give it about a minute or so to answer this poll question. All right. A few more answering there. Give it a few seconds. All right. I think that's everybody. That's going to do. All right. So which of these should be considered regarding service items and tools? Best answer is all the above. To make sure you have plenty of ventilation when you're working in a space. Have a leak detector with you that is rated for use with 454B. Make sure your equipment, vacuum pumps, leak detector, so on, are 454B compatible, and your gauges as well. And it's recommended to have a set dedicated so you're not cross-contaminating. That's no different than now. If you do air conditioning and refrigeration, chances are you have multiple sets of gauges on your truck, depending on what refrigerant you're dealing with. So that's nothing new there. So the best answer is all the above. We'll stop sharing that. Good deal. So we're wrapping up the first part, and we're doing pretty good on time, which is great. Summary. Many processes for the 454B are the same as best practice for 410A. So what used to be considered a best practice, hey, this is what you should do. With the 454B, you have to do that. Meaning the double evacuation, purging with nitrogen, and so on. We'll see that again at the end of our next session. The 454B dissipation system, that's the process that we're using to mitigate any risk of flammability if there happens to be a refrigerant leak. Components of that system are the dissipation board, leak sensor, and the wire harness that interwires with your system to shut down the heating and the air conditioning call, and run the fan to spread that refrigerant out through the air and dissipate it to mitigate our risk of if it becoming or being flammable. Okay. So we're at the end of the first session, which is great. Go ahead and put your information in here. And it's going to seem strange. We'll do this. We'll take a short break. And then when we come back from the break, you'll have to do this again for the second session. So do this now, and then I'll have you do it again when we come back from the break. So I have about 8:30 Central Time. Let's take about 10 minutes, fill this out. You see at the top there, it says end of session 1. Here in about 5 minutes, I'll switch to the next presentation. And it'll be the beginning of session 2, and you can plug that information again. So I'm going to go ahead and kill the camera. And we will reconvene in about, let's see, we'll say about a quarter till. Okay. If you have any questions, throw them up in the question and answer section, please. All right, just a reminder, in about 6 minutes or so, we'll start back up with our session two. Doing pretty good on time, which is that's great. Make sure your information is put in the chat box, and if there's any questions, put them in the Q&A, and we'll answer them as we go. All right, we've got about 3 more minutes or so before we get started. Again, make sure you have your information plugged into the chat box there. I know we just did it at the end of the last session 10 minutes ago, but this is the beginning of the next session. And because it's additional credit hours, it's required for this session as well. So your name, who you're with, your license number for any jurisdiction license, and your NAIT number. There's a couple of questions that's come in. We'll go ahead and wait here another 3 or 4 minutes till we're back from break, just to make sure that everybody's back and got their coffee or beverage refreshed and got a little snack and is ready to go again. All right. We're going to get rolling again here. Maybe I can get you guys gain a little bit more time, get you out of here and onto your day. A few questions that come in. One with the SM480V gauges have a dedicated vacuum port. Can you skip braking with nitrogen since you won't be braking the vacuum? No. The purpose for the braking the vacuum with nitrogen multiple times, again, is to dislodge any pockets of refrigerant that may be sitting there, maybe being held in with some oil or something like that. The double vacuum and braking it with nitrogen is required with the 454B refrigerant. You're doing a sweep of that system with the nitrogen. Okay. See the next question. Isn't the gas running to the furnace more dangerous than the refrigerant? Yeah, it is. The gas going to the furnace is absolutely more flammable than the 454B refrigerant. Absolutely true statement. Why is there a detector in the furnace to detect gas leaks? Great question. Never has been, to my knowledge. Don't know that there ever will be, but valid point. Yeah, that's refrigerant, significantly less dangerous than the gas going to the furnace. Okay. Question: how many PEUs is each session worth? I think it varies. It might vary per jurisdiction. I want to say it's like two credit hours, and I think it's like 1.5 or 2 and 8 hours per session, something like that. I can't remember exactly. For Kentucky, I'm pretty confident it's 2 CEUs per session. I think Vanderburgh County in Indiana is the same. I don't know about St. Louis area. So Tina in our St. Louis branch would be the person that would have that answer. I don't remember exactly. Okay. All right. So let's go on and get on to session 2. We're going to revisit a subject that we covered a little bit last fall when these furnaces first came out, and that's the furnaces with the new near-field communication boards. We've learned a little bit since then, since they've been out. Many of you all have probably installed them already and have already gone through the setup process. We'll walk through that, not necessarily as in detail as we did before, but we'll share a few things we've learned along the way. The reason we brought this back was there was a lot of questions when these furnaces came out, even since we did the training. So we felt like it was good to bring this information up again and talk about how it's going to tie in with the new dissipation system and the 454B refrigerants, and maybe clarify some issues that we've run into with these new furnaces since they've come out. Right here on your screen, the QR code for the service app. If you do not have the Carrier Bryant, depending on which brand you're dealing with, if you don't have that service app loaded on your smartphone, take a minute. I'll give you a couple minutes on this slide and grab that QR code and download that app. You're going to need that app out in the field. See, while you're doing that, see, why does a double evacuation need to be done when changing an existing 454B system, but changing from 410 to 454 on a single evacuation? Again, it's the requirement to make sure that you unlock any potential pockets of that 454B refrigerant before you hit that system with a torch. Okay. It's reducing the flammability. On a 410 system, the double evacuation has always been considered best practice. It's not a requirement, but it was always a best practice to do a double evacuation for the same reason, to get rid of any pockets of refrigerant that might be in that system, or any contaminants, any air that might be in there. So, good question. The reason it's a requirement now versus a best practice is because of the A2L classification of the 454B refrigerant. All right. Does everybody have that QR code? If you didn't get it, we move on. Just go to your app store and look for the Carrier service app or the Bryant service app. It'll have the gear looking thing on its emblem, and you'll see it here in a few slides. So what we're going to talk about is we're going to go back and do a reintroduction of the new furnace board. We'll talk about how you set them up, how you do set up your airflow, and the startup troubleshooting processes with the new boards. We'll kind of got a little commercial of some of the new equipment products that have been released. So we'll talk about that. Talk a little bit about the IntelliSense product or service that's on our mid-tier equipment. And then we're going to go right back to talking about the A2L refrigerant, how it all ties in, and just kind of a reminder of service practices and things like that. As the whole morning is about making sure we all understand how to deal with that A2L refrigerant. Okay, comparison between the introduction. We're going to compare the new furnaces to the previous models. We look at the different components and how we install them and wire them up and how we use the near field communication. So why did furnaces change? They were forced to. Back in 2023, last year, Department of Energy created the M1 requirements that set a minimum level of efficiency for gas-fired furnaces. Okay. And a lot of that had to do with the energy used by the blower. The current product line with the control board did not meet that minimum guideline, so they had to make some changes. They had to do some improvements. Carrier decided, or the factory decided, Carrier Bryant decided, hey, if we got to make improvements anyway, let's make improvements on some other areas that we've been trying to do. So that's where they came up with a higher speed motor in this new board with the near field communication, taking advantage of new technology. By doing that, they've reduced 70% reduction of blower motor parts. So we have one motor fits multiple SKUs or multiple furnaces now versus more limited that we had on the previous. You know, you had the 5-speed motor for the Comfort series, and you had different sizes there, and then a different motor for the mid-tier and the communicating. Well, now we have a motor that can fit multiple applications. So we've reduced the number of blower motor parts. We have a board that'll fit, one board will fit across all the Comfort series. One board will fit all across the mid-tier. One board fit all across all the high-tier communicating systems. There's no more model plugs. No, you don't have dip switches to mess with anymore. So we'll see that as well. We've increased our airflow on a lot of them by going to these new blowers, and we're going to gain and harvest a lot more information from these new boards, as you'll see. Okay. Again, I know these furnaces have been out for a little while. Many of y'all probably installed one. If you have a question or something you ran into during an install, throw that up here in the Q&A and we'll address it as we go. This is just kind of going through the different model lines for the new furnaces. And you can see that the new Comfort series for Carrier, it has a 18-speed constant torque motor ECM in it, and also they all had the 3-segment LCD display with the near field communication antenna built in. On the mid-tier and the Infinity, they also have a terminal on here for supply air, return air temperature sensors. That is for the IntelliSense service that's available. And on the communicating systems, they're going to come not only with the near field communication, but with a Bluetooth module. And then here's the condensing furnace models. Same stuff. The mid-tier and communicating, those motors they're variable speed. They're basically 25-speed selection motors versus the 18 that's in the basic line. For the Bryant product line, here's that information for those model numbers as well. Okay. So components, what's changed? Everything from this blower shelf up is the same as it was in the previous model. Didn't make any changes in the gas heating section, okay? What's changed is from here down, it's the blower motor and the control board. Those are the changes that were made to gain that efficiency, okay? And again, we talked about this for the baseline or the entry level furnaces. It's an 18-speed motor, and it's a constant torque, so you'll select a speed and it'll run at that. For the mid-tier and high tier, it's a 25-speed. They are two-stage cooling compatible, and they have the dehumidification capability. One thing to tell you on the the baseline furnaces or the low-tier furnaces, used to, you could kind of trick one of those furnaces for two-stage cooling operation, where you might set your G call as giving you enough airflow for a low speed fan. And then when you get the Y2 call, you land that on your Y on your furnace board to go to the cooling speed. And you can kind of make that furnace, trick it to be a 2-speed. With the new energy efficiency requirements, we're limited on how much CFM we can move on a constant fan. It's called the ventilation speed. And that speed is lower than a low speed air conditioning system can operate. So, in other words, we can't trick the new furnaces and make them a 2-speed cooling application. They can only do a single stage cooling. So you can see that in the fan speed set up here a little bit, but that's just kind of a thing that I noticed early on is that function's been taken away. See questions coming up. See on the modulating furnace, will the older white and communicating and control have to be changed or upgraded? Yes. You'll see that later on. It has to be the version B or version C wall controls. The old vertical or what we call the Game Boy control, it will not work with the new communicating furnaces. Okay. Just some components in the new board. The display there's a couple of buttons that you can see. That display is going to give you all sorts of information. It'll tell you the status. It'll tell you a fault code. And if you have the mid-tier, it will tell you return air and supply air temperatures as well. Okay. So just kind of look at that board, and I don't know if I can see. I did this the other day and it worked all right. I don't know if y'all can see that or if it's blurry. Maybe if I quit moving it around. Just the different components on the board. You'll use your display at the top. Your NFC antennas right here. All your line voltage connections are across the bottom. You can see the red plug over that EAC terminal. That's because anytime that fan's running, that terminal is energized and that's 110 volts going out. So to keep somebody from accidentally getting onto that, they've covered that. There are 2 buttons, menu buttons that can be used to set up or go through the board here. And then all your low voltage connections into the furnace are on this one pin right here. And then this is your field connections here. You can see this board is just for the base model furnaces, because it just has as you see in the slide as well, has a Y, W, C, G, and R. The furnace, you can't really see it. This is a mid-tier furnace, and it has the Y1, Y2, W1, W2. So that's the differences there in the boards. Okay. Question. You have to install a supply air temp sensor. So we'll get into this a little bit more, but this is something that's come up in the field. You have to install a supply air temp, even if you're not using the IntelliSense thermostat, or it'll flash code 25. If you do, flash code 19 if you don't have the smart thermostat. Factory's aware of that. First, those codes won't affect the operation of the furnace or the air conditioning system. It'll continue to operate. These, we'll talk about that in the IntelliSense section. These furnaces, you don't have to utilize the IntelliSense, or you don't have to use the temp sensors. That's for informational purposes only. It'll continue to operate. Factories realized that about the fault code that pops up. It's a nuisance code, doesn't show up on the thermostat, especially if you're not using the IntelliSense thermostat. So it's just a nuisance thing that is being addressed in future boards. The fix for that is a new software version in the board. Unfortunately, to do that on the mid tier, you have to change the board out. On the communicating systems, you can do an over-the-air software update to the board through the communicating wall control. But on the mid tier, there's currently not a way to field update the software in the board. So that's the only way to deal with those codes. And if you have not experienced that in the field, it'll make a little more sense when we get into the slides about the IntelliSense. And again, here's just a drawing layout showing all the connections I just showed you on the board. Up at the top right, you see that port for the super plug. We'll talk a little bit about that. That is a way to configure a replacement board that candidly, it's like the fire extinguisher hanging on the wall, in case of emergency, break the glass. That's the super plug. But majority of the time, you're going to use your app to make any changes to that board. All right, that brings us already to our first poll question for this section. So let's go ahead and launch that. All right, the new mid-tier furnace blowers have how many speeds? Again, this is the mid-tier. All right, see if we can get everybody to answer that. We're about there. Couple more. All right. All right, we're a little split on this. So about 32% of you said it's the 25 speed on the mid-tier, and about half says the 18 speed, and there was a few that went with the other options. So the entry-level tier or the base model furnaces are the 18 speed, okay? The mid-tier is a 25 speed. We have more speed options in that mid-tier, and we have that we can fine tune that blower, especially when we're using two-stage heating and two-stage cooling. So the correct answer there is the first, or is A, the 25 speed. All right. Reset that. Excellent. Moving right along. So let's talk about how we set the airflow and the blower. The chart's going to look a little different. It's going to have a lot more information on it than what you saw on the old charts from the previous model furnaces. So we'll look at how we read those, how we determine our CFM, and then now we can change the blower speed either through the circuit board or using the app in the near field communication. So this is a blower chart. As you can see, there's 18 selections for this furnace. This is out of the Comfort series or the base series furnace, and it has 18 speeds. And you'll see a default setting. All right. Each furnace, based on its size, is going to give you a limited range that you can set your heating and cooling and constant fan speeds. They're all come out of the box set at a default setting. The question early on was, do we have to go through and set these furnaces up before they'll run? And the answer is no. You can take a furnace out of the box, install it, land your thermostat wires, fire it up, and it'll run. Now in cooling mode, that fan speed is always going to be at the highest setting, because when they build the furnace, they have no idea what size air conditioner you're going to put on it. So they just program the board to be set at the highest fan speed. That way they know they got enough air going. Now that thing may sound like a jet engine if you have a 4-ton drive, if you only have 3 tons of duct, you're going to have to go in and set that, but it'll run. And the heat speed is going to be set at the mid range of what they've tested that furnace to get its temperature rise. And that's where that's going to be set. Your constant fan speed is always going to be set at 1. It's always going to be the lowest setting. So the way we set our fan speed for cooling is we use the chart that you see, and you have your static pressure ranges. So you'll calculate or determine what your total static pressure across the furnace is, and you'll use that scale. And if you say on this particular furnace, I have 3 tons, I want to move 400 CFM per ton, 1200 CFM, but I've got about a 0.7 estimated duct static pressure. All right, so I'll go to my 0.7 scale, and I'll go down until I see the number closest to 1200. I see 1230. So I'm going to follow that over to the left of the scale, and I'm going to set my cooling speed to 14 on that particular example. I'll fire it up. I'll measure my total static across the furnace. If I'm at a 0.7, then I know I should be moving around that 1230 CFM. If I'm measuring a different static pressure, then I'm going to have to make a change in my fan speed setting to get it to where I need it to be. Just remember, every time you change that fan speed, it changes the static pressure. So it's a little bit of a moving target. You just kind of have to fine tune it, narrow it down, and get it where you want it. On the heat setting, I'm going to set my heat fan speed according to my temperature rise. So when I'm doing a startup on a furnace, I fire it up, I let it run, I let it stabilize. I'll measure my temperature rise. Now I want to be about the midpoint to slightly below the midpoint of my temperature rise scale that's on my label. That way I know that's the birthday of that furnace. That's the best it's ever going to run its entire life. I've given myself some leeway either way for, ducts getting clogged up, vents getting closed, things to change in the system. And my furnace can still stay online because I'm well within my temperature rise. Set your heat airflow with temperature rise, your cooling airflow with your external static pressure. So we determine what we want. We can do it a couple of different ways. We can use the buttons on the board and scroll through and set each one. And you're going to use these, there's a better picture of it, reading the LCD display and the menu select button. You're just going to go through this menu. You'll scroll down to your heat blower fan speed, press the next button, and then select the speed that you want. Press it again to save it. It'll flash at what you have it saved at. And then you go back to your menu and go through. That's how you can do it. You can set it up through the board. You don't need the app. Do the same for your cooling blower speed and your condensed constant fan blower speed. Okay. Default settings. I mentioned before, they're going to come out of the box with the default setting. Based on what furnace it is, this is an example of the base tier the furnaces or the Comfort Series furnaces. Depending on the size, it's going to come at a default heat setting, which should be about the mid-range. Your constant fan is always going to be 1. Your cooling is going to be at the highest level. And for each furnace, you'll have a range that you can set the heating fan speed and the constant fan speed. As you can see, the constant fan speed, we can't go up very high on that range for that constant fan. It's not going to let you set that constant fan speed up any higher than that range. On the heating, those are designated. Might let you get out of that a little bit, but you just want to make sure you're maintaining your temperature rise. On the mid tier, or the premium tier, if you're not using the communicating wall control, you can toggle the fan switch off and on the thermostat, and it'll change that constant fan speed. You have like 3 different ones. So sometimes you've been out on a job, you're doing a startup, and you've noticed that fan, I have it on just a G call, it sounds a little different than it did.
Well, toggle it off and back on within 3 seconds, it's going to sound different again. So that homeowner can change that, but you want to let them know that so that they don't call you thinking there's something wrong with the furnace. All right, so let's walk through using the app to set a furnace up. When you open your app, this is what the opening screen is going to look like. You have two options. You can sign in, and that's signing in using your HVAC partner's credentials, or you can continue as a guest. Everything we need to do in these boards, even setting up a replacement board, we do not have to sign in. You can continue as a guest. So you don't have to have HVAC partners login credentials to use this app on these boards. So you're going to select continue as a guest, and then you're going to get this screen. You have an option to connect to an outdoor unit or furnace. So you're going to select connect to the outdoor unit or furnace, and you're going to select furnace. The newer versions are going to ask you if you want to do NFC or Bluetooth. With Bluetooth on the premium tier products, you do have to be logged in to connect to the Bluetooth. You can't, the app won't allow you to connect to a Bluetooth module as a guest. So that's the only caveat there. But you don't need to do that to do anything with the board. You're going to select the furnace, and you're going to go to the installer setup menu. Now you're going to use the near field communication. Once you select installer menu, it's going to tell you to remove the furnace blower door and then tap connect on your phone. When you're connecting to these furnace boards using the near field, the NFC connection, the board has to be off, no power. Okay. It's just like the card that you use to check into a hotel. It's the same technology. That door handle has a battery pack in it that powers up a board, and that little pass card that they give you that has the information. Okay. That doesn't have any energy in it. You just tap that to the door and it transmits that information. Or if you use tap to pay or a tap to pay app, it's the same concept. No power on the board when you're connecting to the NFC. So the NFC chip, as I mentioned, is up here in the top corner. You'll take your phone, you'll open the app up. When you press connect, you'll hold that phone right to that antenna. Depending on what type of phone you have, if you have an Android phone, the antenna is here on the back. If you have an Apple phone, it's on the top. If you have a hard case on your phone, you may have to remove that to get a good connection. Just put it up there. It's going to vibrate. It's going to tell you. You get the ready to scan. You hold it up there. It's going to tell you you're connected. Hold it there for a second or two because it's transferring data. And you can, if you pull it away too fast, you can disrupt that transfer of information, and it'll say it's done, but it isn't done. You got to do it over again. Okay. So once you're connected, you're going to get all of these options of what you can set up on that unit. So you're going to get the heating airflow. You'll see there's a factory default in this example. Then there's a designated range, which is the lighter shade. But you can see on that particular example, you can set it from the speed 3 up to speed 17. It's not going to give you the full 25. It's going to limit because of that furnace model. That furnace model is coded in model and serial number is coded into the board. So it knows exactly what furnace it's in, the width of the furnace, the blower, the drive size, the BTU size, knows all that. It's only going to allow you to set the fan speed to within the parameters that are associated with that exact furnace model. Okay. So on the first image on the left, you can see that it has the furnace model and serial number at the top. You're going to check that. That's the information in the board. Check it with the label on the unit. Make sure a board hasn't gotten swapped with another furnace. Okay. If you do have to swap a board, we can talk about that here in a minute. You can reprogram a board. Okay. So, but we'll talk about that on board replacement. You're going to set the temperature display. You can turn the temperature display on and off on the mid-tier furnace. You can set your high heat airflow. You can set your low heat airflow, or you can let the board do that automatically. You'll set your high cooling airflow. When you go into that menu, we should see that here in another slide. It'll allow you to tell it what size air conditioner you have, what tonnage, and then it'll give you the recommended range for that tonnage. Okay. It's only going to let you select the size of air conditioner that is approved for that size furnace. In other words, it won't let you put a 5-ton air conditioner on a furnace with a 3-ton drive. Okay. Those safeguards are programmed in. Again, on the low cooling airflow, you can set it, or you can let the board set that. And it'll adjust that based on how you set the high cooling airflow. Continuous fan airflow is going to give you that limited range. You can set your heating, cooling, blower off delays. You can tell it on the mid tier, am I using a single stage thermostat or am I using a 2-stage thermostat? If you're using a single stage thermostat, then the adaptive control will determine whether you want to run in low fire, high fire, or low cool, high cool, if you're using a 2-stage outdoor unit. All right. So you go in, you make changes, and then you select OK, and then when you select continue, you're going to get a menu that says, hey, here's the changes that you made. These are the way the current, that's the way the board's programmed currently. The new value, that's the value that you put in there that you want to change it to. If that all looks good to you, you press continue, you scan it again, and it'll download the information from your phone down to the board. Okay. So let me back up a little bit. Once you connect to that board and pull that information up, you can walk away. You've not made any changes yet to that board, and you don't have to stay right at it. You can go sit down somewhere, make the changes you want to make, and then go back and reconnect it and download that information to the board. Okay. Here, I just talked about this a minute ago. You tell it whether you're using a single stage or a 2-stage thermostat for heating and cooling. You can do a 2-stage heat, 1-stage cool thermostat. It'll work just fine. You just got to let it know what it's dealing with. Again, the auto select for the heating airflow. You set your high heat airflow based on your temperature rise. Your low heat airflow, you have the option of letting it auto select, or you can manually do it. Either way. And there at the top right of the slide, you see the emblems for each of the service apps. So earlier on, when I told you to load the service app, if you missed that section, that's the symbol you want to look for in your app store for the Carrier or Bryant Service Tech app. Again, on your low cooling, same thing. You can set it yourself, or you can let the system set it. As of right now, it's going to load on a 2-stage outdoor unit. Low stage is about 75% capacity. So the board's going to, if you leave it for automatic, the board's going to set the airflow for about 75% of what the high speed or the regular high cooling is. Poll question 6, moving right along. All right. Based on what we talked about, what you just seen, what do you think is the best way to set the airflow in the indoor blowers? Selection through the control module, through the NFC, matching the selection and static pressure to the airflow chart, all the above. A little bit of a trick the way that's worded. All right, let's see. A few more people still answering. All right. let's close this off and take a look. All right, so best way to adjust the airflow on indoor blowers, probably the best answer there is all the above. You can, the difference between best and the easiest way to do it is through the near field communication through the phone app. But either of those or selecting through the control module, you can do it either way. But both ways, you're matching your selection and your static pressure to your airflow chart. So really, I'll take all the above on that. You want to go through any or all of those steps, just making sure that on your cooling mode, you're checking it to that static pressure, and on your heating mode, you're verifying your temperature rise. All right. Good news is there's only 2 more of those questions left. All right. Any questions before I move on to the startup and troubleshooting on setting the airflow? Because that when these furnaces first came out, started being installed in the field, that was a lot of the questions we were getting phone calls is how to set the fan speed. Okay. Just a reminder, when you're checking the static pressure on the chart for the furnace, that static pressure, the return is taken in the blower section or after the filter, between the filter and the furnace. The supply is taken between the furnace and the coil. That supply static pressure is not taken after the coil. That chart only applies to what's inside the furnace cabinet. So if you are in like a downflow install or an upflow with the furnace the coil sitting right on the furnace with no spacer in between, you can pull the limit switch out and put your static pressure probe in there to get your discharge static pressure. So you measure the supply static, the return static, ignore the plus and minus sign, add the 2 numbers together. That's your external static pressure. Question came up after you complete with changes on setting up the board, you scan the NFC again to save the changes. That is correct. Yeah, so you'll scan a board once, you'll pull the information up from the board, make any changes you want to make, tell the app that you're done making changes. It'll show you the list of the changes you've made. If that all looks good to you, then you'll say okay, and they'll say scan the board again. You'll scan the board again, and you'll get a notification on your app that says download complete. And then you're done. Then you'll run the furnace and test it. So yes, you have to go back and scan it again to put that information back into the board. All right. We looked at a little bit of that menu that we run through on the board a while ago. So here's some of the rest of it. When you're doing your startup and your setup, the HOD, that's your heating off delay, cooling off delay as well. You can change that. If that fans, if you're on your heating side, that fan, you got maybe a little tight duct work, fan's not running quite long enough, and you build up some heat and trip a limit, you can adjust that. Or the customer's saying, hey, this thing's heat's great, but at the end of the heating cycle, it gets a little drafty, you slow it down a bit. Same thing on the cooling. You don't want to run too long and evaporate all the moisture off your coil. Direction of display. So you change that thing from upflow to downflow. It's also called orientation. And all that does is on this 3-segment LCD display, it flips it upside down. So that if the furnace is in a downflow configuration, you don't have to stand on your head and try to read it. That's all that does. Twinning. If you're twinning 2 of these furnaces, they have to be the same furnace. Okay, you can't twin a new furnace with an old one, and you can't twin an 80,000 with 100,000. They've got to be the same size furnace. You have to use a twinning kit. The twinning kit has a connection between the 2 boards that allows them to communicate with each other. And we have to tell the secondary furnace that it's a secondary furnace. Which one's a secondary furnace in a twinning set? It's the one that doesn't have the thermostat wires connected to it. So default in the board is primary. Primary board says, I'm the main board in control. I'm looking for thermostat input. You put a twin furnace there. If you don't tell it it's the secondary, it's going to look for a thermostat input and it's not going to run. Okay, so that's what the twinning does. Then you get into the info. That's the program, the software, and version number that's in there. That program number, think of that as well, hold that thought. I'll talk about that when we talk about changing boards. And then you can go and do a component test, just like jumping the test pins on our previous model furnaces. You start the test, and it'll run each function, will do everything but fire up the gas. Then if there's any, you can reset the defaults. You can't remember what you changed things to or something's not right. You can do a reset the default. You have the same option in the app, and that puts that board back to the way it came out of the box, and you can start over again. Again, here's the menu that we see in the app. After you've done your installation, there's all your settings. Same thing that we just looked at, scrolling through the menu on the board. When you've done your setup and you're on a new install, up at the top right of your screen in your app, there's a little box with an arrow pointing out of it. That is a way to export a report. You can do this on a startup. You can do this on a service call, and we'll talk about that too. You can export a report that will have all of the information, the furnace model serial number, the date and time that you pulled that information, unit history, any history of any faults that's in there, current fault history. Okay, if there's any current fault history or any faults that have taken place within the last 72 hours, it'll display those. Fault counts. After 72 hours, it clears that out of its memory, but it counts it that it hit that fault so many times. So that's a way you can track through the life of that furnace how many times you're hitting a certain fault if you keep getting a repeat fault. The unit history has all your run cycles, how many times it started, how many run hours, things like that. And then it has a list of your installer settings. Every time you touch one of these furnaces, from startup on, I suggest creating that report, emailing it to your office. It'll come through as a PDF. They can put that in that customer's file. And then going forward, you have information that you can kind of track to see how that system's been working. Let's see here. I got a couple of questions here. See, I answered that one. All right, so a question here, low stage on a 38 MURA, what is the capacity for setting blower speed? Good question. That's a good question. I'm not sure yet if the MURA, yeah, it is. It's compatible with the two-stage. I don't know. I mean, I don't know. I guess my first thought would be I'd kind of go with the same process. If I have a low stage call, let it go at 75% of the capacity. And, the MURA is going to monitor its suction temperature in the outdoor unit. So, yeah, that's a good question. I don't have an answer for that other than just like I said, just kind of what I think I would do, and that would be set it at 75% and see how it works. We have to play with that. That's a good question. Fault codes. This is something that you've seen in our previous model furnaces. This is our fault chart. It lists the particular faults, and under some of the faults, you may have several different options of things that could be going on. With these new boards, we get more information. So this is an example of the fault code table that you'll see in the new furnace. And you can see, for example, on the fault code 14, I now have a 14 with a submenu, a subcode of 1, 2, or 3. Some of the previous fault codes, like if we look at a 14 back here, it was just ignition lockout. We don't know why the ignition lockout. Well, did it lock out after 4 consecutive tries? Did we lose our flame 3 times after 70 seconds? Or was there 7 loss of flame events during a heat request? That helps us narrow down where to look for the problem. Another thing about the faults is, on our previous model furnaces, we just had that blinking light and we had to count the codes. Here we have an LCD display. And also on the previous furnace, what's the first thing you get a call on the weekend? Customer doesn't have any heat. You tell them, go look, and they see the little light flashing through the window on the door. Yeah, what's it doing? Okay, well, try cycling power. They cycle power, or maybe they don't call you the next time. They just try cycling power, see if the furnace will come back on. On the old boards, that fault was gone. All right, you had no idea. On this one, like I said earlier, it's going to store those faults up to 72 hours. You're going to be able to go up to that board because you got to pull the door off to see the display. As soon as you do that, you're powering the board down. You can power back up and read your display, or you can connect to it with the app and pull the fault code up and see what's going on. Other things you'll see on the display that may or may not be a fault code. So over there on the right-hand side, whether it's idle, what mode is it in, they're an active status code, things like that. Okay. Retrieving stored fault codes. You can retrieve it from the board. You want to make sure it doesn't have a call. You power it up, you pull the door off and you scroll through and you find your faults. You go to the fault menu. Again, it holds them for 72 hours and you can clear that out. So I recommend after a service call or after any time you touch that, if there's any faults in that current history, clear it out. It won't clear out the counts of faults. That'll stay in there. So here again, diagnostics, you connect to it, diagnostics, it pulls up a list of fault codes. Reset, you see at the top of that center screenshot where it says clear, you can clear those out. And then there's your unit history, your cycles, fault codes. And again, you can generate that report and send it back to the office. Okay. Let's say you have a failed board. All right. This is a replacement board. I just took it out of the box. Okay. I've not done anything to it. I've not programmed it. So at the end of the classes, this is going back in the box and is still fully usable in the field. Okay. Board it comes not programmed. If you take a board out of the box and you stick it in the furnace and you power it up, it's not going to run. It doesn't have a program. It doesn't know what furnace it's in. The best way to program a replacement board is through the app. Okay. So you go to the app and on that first screen where we selected installer setup previously, we're going to select replace control board. First thing it's going to ask you is what's the serial number of that unit? Now, the thing to remember when you're setting up a board during the install, you don't have to have cell phone service. You don't have to have internet access. All that's done between the app and the board. The board already knows who it is, already has its program loaded into it. You're just changing settings. When we're configuring a board, configuring a replacement board, we have to have either cell phone service or internet access to our app. And the reason is we're going to plug in that serial number and it's going to sync up with the database. And it's going to find that serial number and select the furnace model number and pull that information down and tell you, okay, the serial number you selected is this furnace. And here's the menu for it. So you can do that a couple of different ways. You can either type it in manually or you can scan the unit information QR on the unit label. Okay. So if you're at the furnace, you're changing the board there. If you have good cell service or internet access where you're standing, just scan that and it'll just dump it right there. If the board is not a crispy critter, you can actually try scanning the board. Well, that's later on. You can try scanning the board to pull up its settings. Okay. And then just program your new board to those old settings, plug it in and you're done. A lot of times that board, if you're changing it, if it's smoked or trashed or broken, it's always worth a try to see if you can pull that information up. But just know that if you can't, it'll load the default values on there. That's where that report comes in handy. You can just change the values you need to and set the board and put it in and go. All right, if for some reason you have a phone, you can't get the app loaded, the app won't work or whatever, that's what the super plug is for. The super plug is a service tool. It's a little bitty thing, fits on a keychain. Think of it as the recipe book. Each board has a specific program that it operates at. Okay, and that's the recipe for an 96%, 80,000 BTU, 17 wide, 3-ton blower or whatever. That's a specific recipe. That recipe has a number. It's a 3-digit number. You can use a super plug and plug it into the board, power it up, and you'll go through until you find that menu. And then you'll select that program number. Okay. Then it'll tell that board it's in this size furnace. It won't tell the board the serial number. That won't be in the board anymore. Okay. But you can set a board up that way. There's 3 different super plugs right now. There's one, it was the first one that came out, it just had the entry tier model numbers in it. When they developed the boards for the mid tier, they came out with a second super plug. That second super plug has the entry tier and the mid tier programs in it. When we created the board for the communicating furnaces, that's a third super plug. The third super plug has all 3 of them. Okay. If a new furnace model comes out, there'll be another super plug. Okay. So because of that, it's there. I don't recommend using it. I recommend using the app to set a board up. You don't have to be at the furnace. As long as you know that furnace serial number, you could be sitting in a McDonald's, drinking a coffee, hooked up to the Wi-Fi, and type in that serial number and program your replacement board right there. If you know all the fan speed settings and so forth, you can set it all up, have that board set, and either send it out with a technician or take it to the job site and swap it out, and you're off and running. Okay. But the super plug is there because we're required to have a way of configuring a board without being forced to use the app. All right. A question came up earlier on the communicating furnaces with the new boards. It has to be the B or C control. The O controls will not work. The B control has to be at a 4.47 or later. The C control has to be at a 1.43 or later. What you'll find is if you go out and plug up and you put your system in and you fire it up, the wall control will not find the furnace. And then it's done. It'll go into demo mode. There's 2 things you can do. On the B wall control, you can go into demo mode if you have the micro SD card with the 4.47 or later software. You go to your software update in demo mode, plug the SD card in, you can update it. On B or C, go into demo mode, connect it to the internet, let it connect to the portal, give it a couple of hours or so, maybe go on about doing some cleanup or other install work, give it a couple hours to sync up, and then go to software update, and it'll tell you if it sees that the software update's available. Do the update over the air, go through, do a reinstall or power down, power it back up, and it should find your indoor equipment and you're off and running. Okay. But you have to be with either a B or C wall control on the communicating furnaces, and it has to be at those software versions or later. All right. Let me grab a question here. See, how do I know what version of super plug I have? the HKL 70 EA03. I think the 3 is the newest version. You have to check with the parts counter to for sure, because it should be a superseded. The other way you can find out is pull up go to the parts list for the communicating furnace, and the super plug that's listed for the communicating furnace is the most current one. It'll have all the programs on it. All right. So we did run into some issues on some of the earlier versions. Oh, back to the communicating wall control. We've done our best in each Cook Air branch to go in and update the wall controls we have in stock for the B wall control. We have not done that on the C. The C can only be done through over the air. So you can do it at your office. You can plug it up at your office, connect to the internet through your Wi-Fi at the office, and update it there before you send it to the job site. But any B wall controls, we try to update them as they come in. So as new ones come in, if they don't come in with the 4.47, we catch them as we can. But we'll note on the box it's been updated. If you get one that is the older version, hadn't been updated, you're going to have to update it. Let's see. Question on a communicating furnace does it require any of the NFC information to be done if you're setting it up with the Infinity touch control? No. Just like on the previous version furnaces, if you were using it in a non-communicating, you would use the dip switches to configure your fan speeds and all of that. If you are using the communicating wall control, it ignores the dip switch settings and you set everything up through the wall control. It's the same way on the communicating furnaces with the NFC. If you're using the communicating wall control, all that setup is done through the NFC. Good question. Thank you. I blew right past that a while ago. We were seeing that we were getting an issue with showing a goose egg on our external pressure for our airflow verification. That a firmware update was done, and on that one, it is able to be done through the communicating process. So that can be done. When you hook up, you go for software updates, it'll tell you there's a software update available for the furnace. And you can, through the communicating, you can update the software in the furnace board. Okay. This came up, a question came up earlier. Fault code 19 on the mid-tier or non-communicating, if you're using a communicating system on a non-communicating wall control, if you are not using the IntelliSense thermostat, that's the specific thermostat that allows that IntelliSense process to work. You'll get a code. It's like 19.1. There's some thermostats that you definitely don't want to use a power robbing thermostat on these furnaces. You're going to have all sorts of problems. Or a battery powered thermostat is going to give you some problems. You really want to go to a 24 volt with a common thermostat for these. We were getting some nuisance faults saying, hey, either we don't see a temperature, or there was basically some noise on the Y1 circuit for some of the non-IntelliSense thermostats. There's a software version update for the boards, but unfortunately, you have to change the board out because it's non-communicating. That fault's a nuisance only. It's just in there. It does not affect the operation. This thing, you don't even have to hook up the temp sensors. It'll run all day long without them. So that's up to you. Really no need to change the board to eliminate that fault unless it's just a pain for you. By the way, that fault does not communicate to the thermostat. Homeowner has no idea. It's just on the board. Poll question 7. All right. During startup, a component test can be performed using the menu on the circuit board. Let's take a minute. We only have two options for this one. All right, we need a few more people to answer this. All right, and the poll, share results. All right, during startup, a component test can be performed using the menu on the circuit board. That answer is true. As you scroll through that menu, and it's on the fold-out chart that comes in the furnace as well. If you'd like, I can go over there and get the door for this furnace and show that to you. But you can walk right through there and walk it through the component test. It'll turn the blower on, turn the inducer on, turn the hot surface igniter on. It goes through everything, but just like the previous furnace did when you jumpered out the test buttons. All right. Let's see where we are. All right, we're at a little break here. So let's take 5 minutes, put your information in again. We'll do it this time and one more time. Again, this is what gets you the credit for the class. Plug your information in the Q&A. No, I'm sorry, the chat. And let's take a quick break and we'll get going here. See, it's we'll get going here right at 10 till or so. All right, everybody have their information in there? I'm going to go ahead and keep moving, but just make sure you plug your information in that chat box, okay? All right. This is our commercial time for our little commercial and some stuff coming up. I'll go through this relatively quickly. Again, I want to try to give you, some of your day back. Question just came in. Can you install a 454B system on a different brand furnace? Yes. It's right now it's one way, not the other. So you can put our 454B system, coil and air conditioner or heat pump, on a third-party furnace because we have our dissipation control on it. And our dissipation control can wire into that furnace, provided it's a non-communicating system. But our furnaces currently are not rated for use with another brand of 454B system. And the reason is we don't know their dissipation process or what they're doing. They may have something that's totally interconnected or works totally differently. So currently it's, yeah, you can use R454B systems on another furnace. Can't use our furnace on another 454B system. All right. Good question. Okay. Some of these are coming out and these are going to, I'll fly through these because honestly, these are going to change. If it still has a 24 or 25, it's going to change when we go to the new 454B. The new IntelliSense product, the 2-stage, that's the mid-tier. So those are available now. They'll come with the IntelliSense board that we'll see here in a bit, and it's going to have pressure transducers and temperature sensors in it, where the mid-tier doesn't have that before. Okay. The air handlers, same thing. They're going to come with the new IntelliSense board. Those are already out. Let's see. One of the things you're going to start seeing as soon as they're, made their way through the previous stock on the furnaces and the fan coils. We have right now, it's just stamped in the metal. If you want to run your vent pipe here, your gas line or whatever, you have to knock it out. And majority of the time you're beating the wax out of the side of the unit trying to get that out. Well, they have selected some of the most commonly used openings and they have stamped that completely out. So those will just be a plug that's removable instead of this knockout. And you're going to see that on the fan coils and the furnaces. Okay, new mid FG4 air handler. Again, this is just a new product. These are older slides. These things are already out. Same thing. It's going to have the knockout transition. One thing to note that this replaces the FZ4, the FG4. You have to make sure you get the right heat kit for the right air handler. If you're doing a change out of an air handler, just because that heat kit might look the same, it probably is going to wire differently for the new air handler. And majority of the time you'll find out when you go to try to plug the two plugs together and they're both male plugs. They won't match. So you got to make sure you get the right heater for the right air handler. Same thing on the Infinities. Change to a B, and FE4B again requires a newer air handler or newer heat kit. The new FE4Bs, we're back to, you got to have the B or C. If you have the old vertical wall control, communicating wall control, it's obsolete. It's been obsolete for a long time. You're best to update to the new B or C. This is a product I want to spend a minute talking about. If you have an application where maybe you have boiler heat or hydronic heat, and you're getting rid of a gas furnace and going all electric or something, we have an air handler that's factory installed 110 volt motor, 110 volt controls in it. So this is available 2 to 5 tons. Same thing about the knockout plugs. Is a 2-stage compatible and also handle dehumidification, but obviously you can't put electric heat in it. Can't hook a toaster up to it. Okay, and it's a non-communicating. Puron Advance, that's where I told you your numbers are going to change. That's going to go to a 27 on the carrier model, and it's going to do a 24 245 for the Bryant product line. That's on the single stage. All right, and that's really it on the new product updates. A lot of these slides are a little bit dated. We kind of recycled this presentation from last fall. Some of this stuff's already been out there in the field for a little while. We'll talk about IntelliSense a little bit. For the sake of time, there's a little video that's embedded in here. I'm going to skip past that and just talk to you about what the components are and what IntelliSense does. But you're welcome to, if you go up, you should be able to Google IntelliSense or go to the carrier website and pull up this. Actually, you may not be able to. You may have to go to partners and find it because it's really geared toward you, the contractor, not the homeowner. Before I do that, there's a question that's come up. You can use a Remy Halo and supply, correct? You would just have to install another sensor inside the ductwork. So the Remy Halo, yeah, I don't know about that one. But I'm going to say to err on the safe side, it's probably going to require you to put the airflow sensor in there in the duct as well. Yeah, don't know about that one, but that's kind of what I think. All right. So what they've done on the mid-tier product line for Carrier and Bryant is they put some sensors in there and they put some technology in a circuit board that allows you to gather information. In the outdoor unit, we have 2 pressure transducers, we have 2 temperature sensors, 3 temperature sensors, one on the liquid line, one on the suction line, and one outdoor temp. And those sensors and transducers tie to a separate circuit board, and then it communicates over the 24-volt wire. On the furnace, we added a supply and return air temp sensors, use the same board. We just added some code or some programming in there that will transmit that information over the 24-volt lines. All that information is fed back to the ecobee thermostat with IntelliSense. And if that is connected to the portal, it'll transmit that information up to the portal. Okay. So a few things about this. One, you have to run a common wire because it is using that 24 volts, using information over power on those 24-volt wires. You have to have a common wire run to the thermostat. The ATA wire, that won't work. It has to be a hardwired common. You don't have to have an IntelliSense enabled indoor unit. All you really have to have is the thermostat and Wi-Fi connection to the portal. But you're only going to get information from whatever piece of equipment has the IntelliSense technology. So for example, you change out an air conditioning system, but you have an existing furnace. Well, if you use the IntelliSense thermostat, you can gather the information from the thermostat and the information from the IntelliSense enabled outdoor unit. You just won't gather anything from the furnace. It sends that information back to the portal. And that's the portal that you log into. So you can access that information and pull it up and look at how that system's operating before you go to the service call. You cannot pull that information up, and the homeowner cannot pull that information up at the thermostat. It's only accessible through the portal. IntelliSense is really designed to be a service tool for you to kind of give you an edge on what's going on with that system before you get out there. Or if maybe, you have a service manager that's back at the office, they can screen that information and make some preliminary diagnostics before the technician rolls out to the job site. So that's what the IntelliSense is all about. So again, the outdoor, we're gathering suction and liquid pressures, suction and liquid temperatures. It'll calculate superheat and subcooling for you, and you're looking at an outdoor temp. On the indoor furnaces or fault codes, if there's any, supply air temperature, return air temperature, and blower RPM. So on the furnace, return air temp's already wired, just a little pigtail. It's right here in the return housing. The supply air temp sensor comes taped to your Z-tube right there. You'll install that after your cooling coil. If you install it before the cooling coil, you won't know what your supply air temperature is in the cooling mode. You won't know if your AC is working right. So that's going to install downstream of the cooling coil. Oh, and blower RPM. So it's going to tell you how hard that blower is working to move the air. On the furnaces, it'll also display it on the LCD if you can turn that off if you want to, but it will display the temperature in there as well. On the fan coils, you get a supply and return air. There's no display on the fan coil boards, so there's no readout there. but you do get the supply and return air temperatures. The installation manual will show you where to install those. Again, the system will operate just fine without those temperature sensors hooked up. The IntelliSense has no impact on how the system operates. It's one-way information. Think of it as a communicating system version light. It's information coming back, but it doesn't make any decisions with it. This is the IntelliSense board that's in the outdoor unit. We have a Y and a C communication that comes from our contactor. We have power to the power on an LED says the board's powered up. Comm light saying it's communicating. and they're your terminals for your transducers and temperature sensors. And then when you have it pulled up either on the portal or on your service app, you'll get that information. Okay. And that, again, gives you a little leg up before you go to the job. Poll question 8. Last poll question for the day. IntelliSense equipped furnaces have what additional components? The question is, does a furnace board save any of the IntelliSense information that can be accessed through NFC? No, it does not. You will get from the NFC the same, the only information, you won't get the temperatures. That's really the only difference. And the motor blower speed, but you'll get your fault history. You'll get the fault count, operation. That's information you'll get through NFC that you won't necessarily get through IntelliSense. All right, let's look at this one. IntelliSense equipped furnaces have what additional components? Correct answer is both a supply and return air temp sensor. All right, very good. Done with that. Back to that. All right. That pretty much covers it on the furnace boards. Let's go back and we'll wrap up this morning and revisit our R454B products and look at that. A few things, just a reminder, need to know about Puron Advanced. Carrier's choice to replace Puron. Meets the new EPA requirements for low global warming potential and zero ozone depletion. It's used on all Carrier residential ducted and ductless products and our light commercial products. There's some chiller products that will use R32 as of right now. All new Carrier products with Puron Advanced will include a factory installed leak dissipation that should say all indoor coils, whether it's a fan coil or an evaporator coil. Okay. That meets the UL requirements. The outdoor units, that's not on here. The outdoor units, the cabling to the compressor, the contactor, and so forth are designed to meet the UL requirements to mitigate the spark source. New dissipation control boards can be wired to any existing furnace. So you can put our 454B evaporator and condensing unit on anybody's furnace as long as it's a non-communicating furnace. Okay. Let's see, the question is up here. How do you add a customer to your portal if they change service company? You have to change the access code in the Ecobee thermostat to yours. So in your HVAC partners credentials, you have a Ecobee PIN number that has to be changed in that Ecobee wall control to route that information to your portal. Another good question. Good questions there. I probably should have been saving all these. Let's see. Many of the field service procedures that are required with Puron Advanced were already best practice. We already talked about that. Really, the only thing that's going to change about the process is those corners. We were kind of cutting before. Those little steps we were kind of skipping, think, we could get by with it, can't get by with it anymore. The cylinders for Puron Advance, going to be different color. They'll have the red band around them, left-handed threads where you hook your hose. And instead of a rupture disc, it's going to have a pressure relief valve that reseals, I guess. So it's a spring-loaded pressure relief valve versus a one-time plug. Okay. Again, this is a nice quick chart that shows a comparison in service best practices between Puron and the Puron Advance. When you're removing a component, so you have to remove the refrigerant, still have to recover it, nothing changed there. But this is where you have to do the double evacuation and purge. Where that was a best practice before, is a recommendation before, you have to do it now. Okay. Then you open the circuit. And when you made your repair, you pressure test it, where before that was a best practice. Of course, after you brace something in or, do a fitting, mechanical fitting, you want to pressure test that and make sure it doesn't leak. With Puron, it was not a requirement. It really should have been, but it is now. So you're going to do a pressure test and a leak test. Then you're going to evacuate, and you're doing those with nitrogen. Then you're going to evacuate it, and then you're going to charge the system. Prefer to be charged as a liquid. Another good picture of the dissipation board, just a reminder, it's one board fits all, whether you're communicating or not communicating service, or system rather, and you do have an alarm connection output. Okay, matter of fact, I think it's probably the same slide as we looked at before. There is a wire harness that goes from the board to the sensor, and a wire harness that goes from the board to the furnace if it's a gas furnace application. If it's a fan coil, it's all internally factory mounted. Just another look at the wiring diagram. Again, this shows that the dissipation board takes the signal from the thermostat and sends it to the equipment. So it has a higher level of authority to tell the equipment what can and cannot run. If you're on a communicating system and you're using communicating wall control, the board does communicate. You do still have to send a separate 24-volt power to the board. You don't use your CD on the communicating plug. That power, the R, comes before the fuse on the furnace board. It's right off the transformer output. Okay. A couple of questions here. Let me grab these. Will new units come with charge in them? Yes. Yep. New units will be factory charged. Any issue with horizontal transportation of 454 and service truck? Yeah, you want to transport those. What is it? It's been a while since I watched that video. Yeah, I believe you want those vertically stored in your truck. Let me think about that. I can't remember. I want to say that you could still use your rack, your tank rack, but I could be totally wrong on that. Watch that video again. Now I'm going to have to go back and watch it on the transportation of it, and it'll explain that. Dissipation board come with a communication plug? Yes. As you can see in the slide here. Oh, the plug itself? I don't know. Haven't seen one yet. You'd about have to. Yeah, it'll have to. Because you only get two with the wall control. So yeah, it'll have to come with that plug. But I don't know. I haven't gotten one in yet. We should be getting some in here pretty soon, so I don't know. That would only be on the evaporator coils or the communicating air handlers. Non-communicating air handler probably won't, or non-communicating air handler won't have one. I wouldn't expect. Okay. Again, here is your fault codes for the dissipation board. This label should be on that board cover. There's two LEDs on there. One's the yellow one, that's your status. And the other was a green one, that's the communication. Green one only lights up if you're using the communication connections. This is, again, just a reminder, the dissipation is what we're using to be compliant with UL on this. So we detect a leak, we dissipate that, we disable our heating or cooling system, engage our fan to dissipate that refrigerant out into the space so that the percentage of refrigerant to the air is below the lower flammability limit. You're gonna be in dissipation at least 15 minutes before anything will come on and run again. There is a factory designated location for the sensor. And if you have to reposition that sensor because you're in a horizontal application, instructions will show you exactly where to mount it. Again, fan coil, dissipation board comes factory installed, sensor's already mounted on the coil, and you'll have to relocate it for all horizontal. Is dissipation sensor covered under the same warranty as the coil? It's going to be the standard parts warranty. Yeah, so when you put whatever piece of coil or air handler that you put in, that dissipation equipment is included in that unit's warranty. Done there. Dissipation parts follow, yeah. It's going to go with the piece of equipment it came with. So it's going to be with the evaporator coil or fan coil. So if you're using a furnace, dissipation board doesn't come with a furnace. We don't know if that furnace is even going to have an air conditioning on it. And it doesn't have any refrigerant in it. So there's no dissipation control coming with furnaces. Nothing's going to change there. It's going to come with the furnace coil. We walked through the process of testing the sensor and getting those 5-volt DC measurements. Again, on those, there's four wires running to the sensor. The outer two are 5-volt DC power supply to the sensor. The middle two are communicating. You unplug the sensor from the board should lose communication to the sensor and throw a fault. If you walk up and it's plugged up and it's showing that fault, that's when you're going to unplug and check those voltages. All right, last one. So here is what I'm going to ask. For the final time, put your information in the chat box. If you have any questions over anything we talked about, put those questions in the Q&A. And the thing that I'll ask is if you give me some feedback on the class today. How did it go? What went well? What didn't go well? Put that in the chat as well, if you would, please. That just helps me, make sure that I'm giving you guys a good quality class and I'm giving you the information you're looking for. If there's some other information you'd like to see, let me know. I appreciate any feedback on anything with the exception of my hairstyle. I can't do anything about that. So I appreciate it. I'll answer questions as they come in. Let's see. Are the 454B coils compatible with dual fuel? Yeah, I do believe they're matching the same compatibility as like the current coils, just with the specific 454B outdoor units. I haven't really looked up yet to see if there's ASHRAE ratings or AHRI ratings for dual fuel. I'd have to see that, but there's the question now on the V coils that they're starting to rate them for heat pump. We're just gonna have to see how that plays out. So get that question. Dual fuel with hydronic heat. Will it shut down the hydronic heat? That's a good one. So what I'm thinking you have here is you'll have like a fan coil heat pump with a hydronic coil instead of electric heat. So you're energizing that hydronic valve with your W. Yeah, it's going to shut down that W. So, yeah, that's just part of the process that it's going to do. Yeah, it will shut that down unless you don't wire it up to shut that down. All right, well, folks, that should be it. Just make sure I've got all your information plugged into the chat. Any information or any recommendations that you want to throw out there at me, I'll take them. I appreciate the attendance and the attention. Thanks for joining me this morning. I'm giving you back some of your time today. So if you're still with me, thanks again. Have a great day. Let's see. Question: what about auxiliary heat kit and fan coil? Yes, that, as we saw in the wiring diagram, the W out, the W to the fan coil has to go through the dissipation board. Now, my question back to that, I disagree with the diagram a bit. It showed on a heat pump application that our W output from the heat pump for defrost was between the dissipation board and the fan coil. So effectively, that would allow the heat kit to potentially be energized if that unit was in a defrost during a dissipation event. I believe that wire should go to the WN on the dissipation so that when we go into an event that's not going to, there's no potential of it energizing those electric heat strips. But yeah, it will kill, when you wire up that dissipation board, it's going to kill that W out, shut off the auxiliary heat in the fan coil while it's in that dissipation process. Once it is cleared, not sensing any refrigerant, and it's gone through its time delay, it will re-energize and let everything come back on according to the call from the thermostat. Guys, thanks for the comments. I appreciate it. Thanks for the feedback. Again, throw any questions up here if you have any questions. If not, once you've plugged your information in for the final time in the chat, and any comments you want to share, you are free to resume your day. Thank you, and hope you all have a blessed day.